I wanted to talk a little bit about the material in Chapter 9 or Module 9 in the online content, and some of the older textbooks it is Chapter 9, and some of the newer textbooks it may be a different chapter number, but you're looking for the chapter on interfaces and polymorphism. So I wanted to talk briefly about interfaces here. So I'm going to follow the example that they have in the textbook. And one thing I want to show you is I've set up my data set tester program. But if you want to add an interface to a project, you're going to do new file like we've been doing, but you're going to select Java interface, not Java class. Then you're going to come in, and if you're following the example in the book, you're going to call it measurable, and then you're going to finish. And we're going to see that, notice we don't have public class anymore. We have the words public interface, and that's a little bit different because we've been dealing with class files. Now we're going to deal with a different type of file called an interface. An interface conceptually gives us a way to reuse code. So if we can find a generic algorithm, we can make it so that different object types can use it. And we do this through an interface, creating an interface and then implementing the interface. In the book, they point this out that we can, if we can make a routine or we can write code that's generic enough, we can turn it into an interface. And so they're showing you an example where they have a bank account object and they want to go through all the bank accounts and figure out which customer has the highest balance. And they're also adding up the total amount of funds in everybody's bank account so they can see how much money total they have on deposit in the bank. And they're also counting how many accounts they have. So they can figure out that they have 100 accounts, they have $1 million in deposits, and Donald Trump has the highest balance, and whatever his balance is. So they've got this little algorithm, this add method. They pass in a bank account object, and then they sum up the balance of the one that they passed in. They're keeping a running total of all the dollars that are on deposit in the bank. Then they're trying to figure out who's got the highest balance, and then they add their counter so they can know how many accounts they have. And so what they do is the first bank account that comes in, by default, that balance gets set to the highest balance. And then the next account that comes in, they compare its balance to the highest balance that they just set. And if it's got a higher balance, they swap it, and the second account's balance becomes the new max balance. They take the third, compare it to the max. If it's less, they just keep the second account as the one with the highest balance. And that's what they do. They're just comparing each account and deciding if the one that they have identified as the max is still the max, or do they need to swap it with the one they just read in. Well, they've got also a coin class. And they're doing the same type of thing with the coin class. They have a handful of coins, and again, they're keeping a running total of how much in value. I have $1, plus I have a quarter, plus I have a penny. So they're keeping a running total of the amount of change that they have. And then they're keeping a total count of how many coins they have. And then they're trying to figure out, okay, the first coin that came in is a penny, so by default that's my maximum highest value coin. The next one that comes in is a dime. The dime is higher, so now I'm going to make the dime my max. And now another penny comes in. I just keep going because the dime is still the highest. Now a quarter comes in. I replace the dime with the quarter as the highest, and they're doing that. So they're doing the same exact thing whether they're comparing bank accounts or coins. They're finding the one with the highest value out of all the ones they have. They're keeping a running sum and a running count. So both of those algorithms are exactly the same. The only difference is in one case you're passing in a bank account object, and trying to find the max balance. Another, you're passing in a coin object and you're trying to find the maximum coin value. So since this algorithm can be made very generic, we can write it once, or well, we can implement an interface so that we can use it with different types of objects, and we can reuse that algorithm. So the way we do this is through creating not a class, but creating an interface. So let's think about this idea of having a generic algorithm, whether we're dealing with bank account balances or coin balances. So if we're a bank, we're going to have bank account balances. We might be tracking the highest value coin that we have on hand. How many total coins do we have? How much in dollars do we have in coins? So it's logical that in one project we might have a coin class and a bank account class if we're dealing with a bank, okay? So if we were putting this together, we might sit down and say, okay, I'm in a bank, I've got my bank account class, and it's going to have all the stuff. Just ignore this implements measurable for now. You would have public class bank account, it would have a balance, a name, an account number, you would have a constructor, you would have your getters and your setters. Same thing with coin. You would have the value of the coin being 25 cents, 10 cents, a dollar if it's a dollar coin, a cent if it's a penny, and then you would have coin name like quarter, dime, penny, dollar, half dollar, etc. So we would sit down to write this and we would say, okay, I've got a bank account, I've got a coin, and I realize as I'm writing this that the algorithm for tracking the total dollar amount of cash on hand and counting how many bank accounts and finding out the highest balance bank account, that algorithm is the same when I'm dealing with coins. I'm counting how many coins, total dollar amount of all the coins on hand, and what is the highest value coin that I have. So the algorithm for that is the same. Okay, and so now instead of having to put that code twice in two different files or whatever, I come up with the idea to create this data set. So now I've got a third class. Oh, sorry, wrong one. So I come up with the idea to create this data set class. And so I say, well, I'm going to put the generic algorithm in this data set class. If I don't make it generic, what I end up having to do is I have to have it pass in a bank account. So I have to have one version of data set for bank account where I've got private bank account maximum and I pass in bank account X here. Then I would have to have another data set where instead of measurable maximum I have coin maximum and coin X. So I could end up needing multiple versions of data set that have the same methods, but I have to have them created to handle either bank accounts or coins. And so if I want to have a more generic algorithm, what I need is a way to have some type of generic object. So whether I'm passing in a bank account or a coin, I don't care. My data set code doesn't care if a coin object's coming in or a bank account. It understands I'm getting the maximum, I'm keeping track of a sum, I'm keeping a counter, and it lets me do what I need to do, whether it's bank accounts or coins. So I can write this data set object where here I'm just tracking, the sum of all the deposits I have or the sum of all the coins I have. This is just a straight counter, like how many bank accounts do I have? How many coins do I have total? Here's the trick. If I want to make this generic so I'm not having to write a data set method for bank account objects and one for coin, if I want this to be generic, I want to have this measurable object that I'm going to allow it to hold a bank account or a coin. And then in my generic method here where I'm figuring out the highest balance or coin value, I'm going to pass in either a coin or a bank account through this measurable object, this generic object. And I'm going to have a get measure method that's going to allow me to get either the bank account balance or the value, 25 cents, a dollar, 10 cents of the coin. And then if this is the very first object that's coming in, the first bank account, for example, I'm going to default that to being my maximum. And then every subsequent account that comes on, I compare it to what I said was the max. And if the max that I think I have, the max that I have is less than the new value coming in, I swap them here. That's all I'm doing. So I've created this generic way in theory to pass in any type of object that has some type of balance or value that I want to track the maximum of. And so here I've got this other method that returns the maximum value. So at the end of the day, when I've got all 1,000 bank accounts I have run through this add method, at the end of the day, the very last line of code in my program might be system.out.println, and I'm going to return the maximum. So I know that the highest balance I have in an account is, say, $1 million, where the highest coin value I have is a dollar coin. Okay, so this is the method that after I get all the objects passed through here and I've figured out what the maximum is, I want to print out what the maximum value is. So I have to have a getter method to do that. And because I don't know whether I'm dealing with a bank account or a coin, I've got to have a generic object that handles bank accounts or coins correctly and gives me back the value. And that's what this is going to do. So how do I tie all this together? The idea of data set, the idea of this interface, and the fact that I want coins and bank accounts to be able to be passed to data set and handled correctly. So this measurable interface, and remember I said this is where you do file, new file, and instead of choosing Java class, you choose Java interface. This is where the interface comes in. Notice that in an interface, I do not have code implementation. I will not have the body of any of the methods that are specified. They are abstract. They're not implemented here. They're only set up. The return type, which can be void or double or string, any valid return type, and the name are specified here, 2 parentheses and a semicolon. And notice I don't have to make them public. They are public by default. Every method in an interface is public by default, and it never has a body of code. It looks just like an empty shell. So it's basically just enforcing the idea that we're going to have a get measure method in any class that uses the interface. So now we've got one name for this method that's going to help us identify the highest balance or coin value. It's going to be called get measure. And I also want to know the name of the bank account holder, the account holder that has the highest balance. I want their name. The coin that has the highest balance, I want to know if the highest coin I have on hand is a quarter, a dollar, half dollar, what is it? So instead of calling it get name, because I thought that would be confusing, bank account holders have names, but do we really have coin names? I could have called it get name. I just called it get identifier, get ID. So I'm running out of time. I'll probably have to do another recording on this. But here's the deal. This is the way an interface looks. This is correct. It looks strange to us. We've not done anything like this. Remember, the methods are abstract, meaning there will never be brace and then code and then brace. It will look just like this with the name, paren, and a semicolon. Of course, you could, if you needed to, you could pass parameters here, I suppose. And they're public by default, so you do not put the word public. Now, how do I help bank account and coin understand that I want them to use this get measure? I want them to have each to have a method called get measure and get ID that returns their specific information. I do that by putting implements interface after the name of the class, and then I must have the implementation, the code for get measure and get ID. So for a coin, get measure returns the value, get ID returns the coin name. For a bank account, those same methods return name and balance. So you see what I'm doing here? I'm setting up the interface to say anybody that implements me must have these two methods, and it must be specific to their instance variables. Get name is going to return name, get measure will return balance. Here I'm returning value and coin name. Now